Hello everyone. It's December and we have our Patreon live stream. Hello everyone. It's December and we have our Patreon live stream. Can you hear me? Can you see me? Let me know in the chat room while I check all of the other little technical details so we can get this show on the road. All right. Let's see. Why can't I get the right page up? Oh, no. 1 second. I'll be right with you. Please hold. Your video is very important to us. This call may be recorded for quality assurance and security purposes. All right, great. It looks like we have live video happening as we speak, and everybody can hear me clearly. Woohoo! Very good. How's everyone doing? It's December. Everyone's getting ready for the holidays. I hope you have a wonderful time with family and friends over this holiday season, and you enjoy that very much. I certainly intend to. We are ready to get started with our Patreon December live Q&A. I hope you've been asking questions. I know you have, because I went over them and there are some really, really good questions this time. If you don't know, you can ask the questions. In fact, this is one of the key values of being a patron, is that you can ask questions directly, and you can also vote and comment on questions, and I will answer them during the monthly live stream. So if you haven't taken the opportunity to ask questions, please do. And voting is very, very important. I probably only have time to answer about 12 questions to 15 questions in the 1 hour time that we have allocated. Now, I can hear you screaming, stop wasting time. We're already 5 minutes in. That's 2 questions you could have answered by now. Don't worry, we'll run a bit late at the end of it so that we can get everything answered. If you vote, that guarantees your questions go further up in the queue. Now, that doesn't mean vote brigade. Please don't do that. That's rude. But instead, just vote for the questions you think you really want to see answered. And the more people who participate in the vote, the more accurately this will reflect the general interest of the community. And I'll get to answer the questions that are the most important to you. Now, that, of course, means that out of the 25 or 30 questions that are currently on the board, I'll only be able to answer 12 or 15. What happens to the rest of them? Well, they get deleted every week. They don't stick around to get an early start on voting for the next week, because that would skew the results. So instead, what we do is we delete them every week. If you really want to have a question answered and you find that you've submitted it once or twice and it's not getting the votes it deserves, consider rewriting how you phrase the question. Provide more detail, provide more information, make the question more interesting to the audience, and that will get it more votes, and then we'll get it a better chance of rising to the top and getting answered next month. And do not despair. You can submit the same question again and again. Also, ask questions for beginners. It doesn't all have to be about the L2 protocol field in the sub-HTLC of the secondary SegWit upgrade that's a soft fork on the side chain of the shard. It could be just, well, what can I use Bitcoin for? Or what do you think about wallets? Or what does an address really look like? Or why is the QR code in that funny way? Whatever it is, beginner questions are absolutely welcome. We've all been beginners at some point. And this really is a live stream that's geared towards answering beginner questions. Those have the best value. So ask questions for beginners too. Let's see. Back in the chat. And a couple of people are asking, how do I submit questions and vote for them? Well, the link is in the monthly invitation. If you go back, if you look at the Q&A tag on the Patreon homepage, you'll see all of the past Q&As. The link for every month is the same. The questions just get cleared out as soon as we finish the live stream, and then you can start submitting questions for next month. So you'll find the link there. It's on the antonopoulos.com site. And that's where you vote. That's where you submit questions. You'll find it in every Q&A posting, including the reminders where a link to the original Q&A announcement in every month for the past 12 months is the same link. And this Q&A will indeed be known as the Rainbow Tablecloth Q&A. Marvel in the collection of colors that I have brought to the table this day. I used to do Q&As where the frame was right up here and you had a blank wall behind you, and it was my big head bouncing around against the white surface. And quite honestly, that was boring. It was visually uninteresting. It was the same gray background all the time. And no matter how many colorful shirts I used to wear, it didn't make up for it. So we've changed the format a bit, pulled back a bit, given a bit of a broader view. I like to add some little color, a bit of different variety on the background. So it's not just a blank wall and you get the rainbow tablecloth. You get some horticulture here, some green, some ecological messages coming at you. And this time I'm going to try to do some video cuts. So unlike many of our previous Q&As, which are single camera focus, we've got one for the live stream and one right behind it recording in high quality 720p. This time I actually have a third camera right over the laptop so that when I turn to the laptop in order to read the question and read it out to the audience, I've got a straight up view this way. And we're going to try and get our video production assistants to cut from one to the other. It's going to be very exciting, just like you see on the news, very high quality. I assure you, only the best. This tablecloth alone cost 7 Bitcoin. Yes, no, it didn't. But anyway, let's get right down to it and start with our questions. All right, our first question today comes from Topi. Government sanctions Bitcoin addresses and censorship resistance. The full story is from a link to the US Treasury and one of their press releases where, under a government order, the US Department of Treasury announced it would put 2 Bitcoin addresses under sanctions because the people using those addresses were recognized as Iranian ransomware hackers. These hackers used international and US-based crypto exchanges to launder money back to Iran through the legacy banking system. The order states that all property and interest in property of the designated persons that are in possession of control, blah, 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 are blocked, and US persons generally are prohibited from dealing with them. This order is prohibiting entities from sending and receiving funds to these 2 specific Bitcoin addresses. What does this mean? Does this mean that miners would have to drop these transactions leading to the addresses from mined blocks? Does it mean that this is a censorship attack vector against Bitcoin's censorship-resistant feature set? And if these sanctions become a trend, wouldn't it be possible for anyone to try to enforce or show compliance to these sanctions without having a majority of the hash rate? So what does this mean for Bitcoin censorship resistance? That is an excellent question, Topi. So first of all, let's understand the magnitude of this tremendous blacklist that the US Treasury has created. They have blacklisted not 1, but 2 Bitcoin addresses. 2 Bitcoin addresses out of a total Bitcoin address space of 2 to the 160, which is 160-bit, the address space, which means that they have blocked 2 out of 1.461501635 times 10 to the power of 48. That's 10 with 48 zeros. Now, I'm not that good at math. I had to pull out my calculator in order to figure that one out, but I think that leaves a few addresses not on the blacklist. By my calculation, 1.46 times 10 to the 48 with 48 zeros after it minus 2, which is still plenty of addresses. Now, considering the fact that your average wallet or laptop computer can probably generate about 1 million addresses per second, that would mean that, that's been 15 million addresses just since I started saying that sentence that I could generate in order to have new places to receive funds. This entire concept is ludicrous. It represents a fundamental misunderstanding. Or does it? You know, in some way, what it is the US Treasury trying to apply its authority on this novel medium. And they're going to start small, and this is clearly going to escalate. This game of whack-a-mole cannot be won by technical means, but it can be won by political means. And the political means are to apply pressure to any entities that dare to include or not enforce the block or the blacklist that are regulated entities. And what this really demonstrates is that when you have an environment where you have a decentralized currency where no one is in control, and around the perimeter of this, you have a number of centralized regulated entities like the exchanges, then this is going to create a significant conundrum, because those centralized regulated entities now have to conform, comply, and really adapt to this absurd, ridiculous regulatory scheme where they have to blacklist these two addresses. And now there's two, soon there'll be 200,000, soon there'll be 200 million, and the addresses will be updated every 10 seconds, which means having a live feed to the blacklist and maintaining compliance at all. It's a ridiculous scheme. It fails completely to achieve any of the goals. If you really believe that the goals are to reduce the use of money or financing for terrorist activity. If, on the other hand, you might have this crazy conspiratorial idea that the purpose of these regulations is not to prevent terrorist financing, because they obviously fail at that goal, but instead to further expand the power, control, and authority of various national governments over the life of its citizens, and to create a completely captured financial industry that is a surveillance mechanism of control that pervades the life of every person, thereby completely destroying democratic institutions, balances, and things like that, then you would be right. So what does this do? It furthers that goal. It furthers the goal of strengthening the surveillance system. It furthers the goal of strengthening financial controls, not for the purposes of actually controlling money, because we all know how sanctioned countries like these are funded. They're funded through banks. But it serves the role of basically extending authoritarian control over citizens. It's going to be completely ineffective, practically speaking, in Bitcoin, and is going to mostly affect the legitimate, legal, regulated entities that operate on the fringes of Bitcoin, the exchanges, the merchant services, etc. For private individuals, for the miners who are anonymous, obscure, and decentralized, it doesn't create any situation. What it does, in fact, demonstrate is why it's important to maintain the anonymity of miners and why it's important to maintain the decentralization of the system. So that's the latest on censorship resistance in the Bitcoin space. Things are going to get very, very weird over the next few years, as various entities around the world try to grapple with this thing that doesn't fit any of their preconceived notions, regulatory schemes, or environments. And as John says on the chat room, they banned a number. They banned a number. Well, in Australia, the law of Australia supersedes the laws of mathematics. So why not? Why not ban a number? Just because it's pointless? Hey, exercise of power is for the pursuit of power itself. The means are the goal. Second question comes from Sue. Sue, what if governments spent trillions of dollars to invoke a 51% attack on Bitcoin? We've heard of 51% attacks on Bitcoin before, and the cost of doing so projected to be in the billions. But what if governments stand to lose trillions when Bitcoin becomes mainstream? And why wouldn't they spend a fraction of that cost to invoke a 51% attack, however long it would take to do so, to make it obsolete? New projects may potentially emerge to try and replace that gap, but if an attack on this scale would succeed against the largest, most well-known and secure BTC, then wouldn't that set an example of things to come for other cryptocurrencies that would dare follow suit? Thank you. This is a question I've had asked many times before, and really, it's a very far-fetched scenario for a number of reasons. It doesn't make any sense to attack cryptocurrencies in that direct way. The first reason is that this kind of attack would be entirely ineffective in achieving any of the perceived goals of an attack. So if the goal is to discredit cryptocurrencies, governments are already doing that by trying to associate cryptocurrencies with bomb hoaxes and terrorists and drug dealers and all kinds of nefarious activities, even though, of course, everybody knows that all of those activities are funded 10,000 times more with US dollars on a daily basis. But That's not the goal. What if the goal was simply to cripple the network and create questions about the reliability of cryptocurrency itself? And again, that really is achievable, but it is very little effect for very much money. So yes, governments could spend billions of dollars. They'd have to first spend billions of dollars buying up a whole lot of hardware secretly so nobody notices they're buying up all of this hardware and building up a parallel mining infrastructure to rival the existing mining infrastructure. First of all, that's an investment that is enormous, and it requires not just an investment in hardware, but also an investment in warehouse facilities, operations staff, blah, 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 blah. Then they would attack this computer system. Now, here's an interesting thing. There are certain countries where the rule of law still kind of works or kind of matters. And so what happens if the government uses its tax money in order to attack a private enterprise and a private network on the internet as if it's a hostile power, thereby destroying the business and livelihood of, well, they don't care about you and me, but some very important rich people in Silicon Valley who have invested a lot of money in this. They're going to get sued. They're going to get their asses sued off immediately for launching an attack like that, which would be hilarious. Secondly, if the attack fails in any way, all that does is actually prove the opposite. It proves that cryptocurrency is stronger than people thought, which is fantastic marketing. That settles the question. I think most governments are smart enough to know that cryptocurrencies are much more effectively attacked through indirect, subtle means by keeping a lot of ideas in the gray area. Now, imagine the impact it would have if the IRS, for example, made you pay capital gains on every transaction you did in Bitcoin, even as small as a cup of coffee, thereby devastating the retail application of cryptocurrency. Oh, wait, they did. What a brilliant move. That is far more effective in damaging the reputation of cryptocurrency, because then they can go on TV again later and say, well, nobody uses it. You can't buy anything with cryptocurrency. It's only really used in countries that are under crisis. Why would anyone use it in retail? Well, I'll tell you why no one would use it in retail. Because for every 10 transactions you do, you have to do 10 pages of a tax return report at the end of the year. So that really makes it very difficult. Attacks, a 51% attack, will only achieve minor double spends, disruption of the network, and it's really a denial of service attack. And of course, there are countermeasures. As soon as the government starts attacking the network that way, causing denial of service attacks, they would create all of the necessary pressure to bring consensus around a proof of work algorithm change. A proof of work algorithm change, which in a single stroke over perhaps a couple of days of upgrading various nodes, would render $1 billion worth of hardware useless and relegate them to the scrap heap and stop the attack and move the attack to another vector. Now, of course, then we'd have an attack against GPU or CPU mining. But then governments would again have to compete against a very much broader decentralized network. And if they keep doing these kinds of attacks, what they're going to do is cause the spontaneous evolution of countermeasures through all of the concerted efforts to thwart these attacks. And if you believe that the innovative potential of a bunch of weirdo cypherpunks can in fact exceed the imagination of big governments, then you already understand why, in the end, cryptocurrencies win that kind of battle. They win it again and again and again. And what arises out of the ashes of their failed attempt is a far more stealthy, far more resilient, far more venomous form of cryptocurrency that's even harder to control. And they've achieved nothing while spending billions on a questionable attack. And in a democracy, they'll get punished for that too. Let's check in with the chat room, see how you're all doing. I'll have a glass of water right now. How's everyone doing? You still there? I think we need to make an immediate decree that demands the increase of the use of emojis in the chat room. I believe that we are currently seeing very few, an insufficient number of emojis in the chat room. So come on, people, step up. Let's see more emojis in the chat room. Next question is called Moore's Law and Bitcoin Scaling. Andrew asked about Moore's Law and Bitcoin scaling. It's been nearly 6 years since the 1 megabyte block size debate began. If Moore's Law has held true, computational speed and memory capacity should have increased by a factor of 8x since then. Accordingly, do you think decentralization would be compromised by increasing the block size limit from 1 megabyte to 8 megabytes? Can the average node now handle an 8 megabyte block as easily as it could a 1 megabyte block in 2013? That's a great question. So first of all, Moore's Law isn't exactly a doubling every year. It was, at its peak, an approximate doubling every 18 months. Furthermore, we are already seeing the fact that Moore's Law has slowed down because in terms of pure increase of the number of transistors on a chip and increase of clock speeds and things like that, things have slowed down. And of course, everybody's writing articles as to why we've hit a wall and we'll never exceed it. I'm skeptical about articles like that because we've heard that before. But nevertheless, we're not quite at a factor 8x. But that's not the problem. The real issue isn't storage and it isn't CPU capacity for being able to validate blocks. The really important bottleneck in decentralized open public cryptocurrencies and blockchains is network bandwidth and network latency. And Moore's Law has not operated on network bandwidth at anywhere near the rate it's operated in CPUs primarily, but also in hard drive storage. In fact, one of the big problems with network bandwidth is what's known as the last mile problem, which is that, yes, you can stuff 100 times more into an optical fiber than you could 10 years ago, but the problem is that optical fiber hasn't reached here. Maybe I have coax if I'm in an advanced country. There's a few very densely populated first world developed nation metropolises that have fiber to the home. But that's a fairly rare phenomenon. It represents a tiny percentage of the overall installed fiber. Maybe you have coax through your cable modem. We're looking at speeds of about 100 megabits, and it's kind of been stagnant in terms of development. Then if you go down to DSL, then you're really looking at speeds of up to 25 megabits at best. Most rural areas, you'd be lucky if you get 10 megabits, and in many cases, you can't even get half that. So what we're talking about is the impact these kinds of choices have on decentralization. So bandwidth is an important consideration, and this has an impact not only on people running nodes, wallets, and other activities on the Bitcoin network, but also, more importantly, on people running mining. So the end result of putting pressure on bandwidth and latency would be further centralization of mining. Mining is already centralized because of its reliance on chips. Furthermore, the other impact it has is on what's called IBD, or the initial blockchain download. And the initial blockchain download is when you start a node completely fresh with no reference to anything other than a single hash of the Genesis block, and you try to bootstrap it to get the entire blockchain bootstrapped off the Genesis block, which means that you have to download the entire blockchain. Not only download it, but then validate every transaction in every block from the beginning while simultaneously changing the rules as you go along, as the consensus rules have evolved. Essentially, what these nodes are doing is they're going back in time to January 3rd, 2009, and they're replaying history as if it's happening in real time as fast as possible. Now, that initial blockchain download time takes at best about 6 hours on a really, really, really powerful machine with very good bandwidth and able to download 250 gigs at this point in Bitcoin. Almost impossible to do on Ethereum right now. And we see these scaling problems on many different blockchains. So again, that affects the decentralization of nodes. And so Moore's law isn't the be-all, end-all of the scaling problem. There are broader scaling problems that have to do with bandwidth. There are scaling problems that have to do with unequal access to hardware. And there are scaling problems which relate to how you bootstrap a new node for the first time, all of which means that increasing the block size may be possible to increase at this time from 1 meg to 8 meg. Maybe. I'm not entirely sure it is necessary or advisable to do that on the base block size. There's another consideration, which is my personal opinion in the scaling debate, which is that the scaling debate demonstrated that we have a very narrow window in which we can see changes to the base protocol. And after that, eventually it will be impossible to make any changes because of a lack of consensus, because of ossification of the protocol, because the protocol has been embedded into too many hardware devices. So then it becomes a matter of choices. What are the changes that need to be done in the base layer? And what are the changes that can be done in the base layer, but could also be done in layer 2? My personal opinion, privacy is the change that needs to be done in the base layer, and it needs to be done before the window closes. Scaling can be done in the second layer quite effectively. And we will also need some scaling on the base layer in order to support even more scaling on the second layer. But our real focus right now should be privacy, not increasing the block size further. That's just my personal opinion. Okay, I've seen a significant and very reassuring increase in the use of emojis in the chat room. Thank you so much, everyone, for putting in the effort. I would now like to see some full sentences made entirely of emoji. Next question from Drew. The next Bitcoin protocol update. What's the latest on Schnorr signatures, MAST, Graftroot, Taproot, and when can we realistically expect to see these features? So that's a really great question, Drew. And in fact, I was reading an update, which was a summary by one of the core developers who's working on both Bitcoin as well as Lightning Network, Rusty Russell, who did a summary of some of the latest, I believe it was Rusty, who did a summary of some of the latest changes and summarized kind of the expected state of the next big upgrade to the Bitcoin Core protocol, which is called SegWit v1. Now, SegWit v1 is not SegWit that we already have. The one we already have is SegWit v0. And the reason it starts from 0 is because the version of the scripting language inside SegWit, which is actually 1 byte in the protocol, as programmers do, is indexed from 0. So we start counting from 0. The SegWit that was introduced by soft fork into Bitcoin in August 2017 was SegWit v0. The next upgrade is going to be called SegWit v1. And that refers... This is not kind of a project version. This is literally the scripting version number that goes in the protocol that tells you what version script you're trying to satisfy in the Bitcoin script language in order to spend a UTXO. And with V1, which is going to be the next upgrade, this can happen by a soft fork. A number of things are being introduced simultaneously. The first one is a new signature mechanism called Schnorr signatures, which provides a number of significant improvements. A change in the signature format that reduces it from, I believe it's 73 bytes at the moment down to 64 or something like that, or 68. A new version, which is Schnorr, which allows signature aggregation, smaller signatures, and a number of other really interesting features that come in later. Taproot, which is a privacy enhancement that allows you to have a number of complex scripts all present the same as a single public key payment. Which is a great privacy enhancement because it means that if you're using complex scripts, whether Lightning, multi-signature scripts, time lock scripts, or various other privacy enhancing scripts, perhaps confidential transactions and things like that, then no one can really distinguish that UTXO from a UTXO that's simply a payment to a public key. And that really enhances privacy because you can use privacy without sticking out like a sore thumb. MAST, which is Merkleized Abstract Syntax Trees. This is the ability to have a complex script expressed as a binary tree with a Merkle root, which allows you then to pay to the root of the Merkle tree and execute any one of the branches without revealing the contents of the other branches. So you say, okay, there's this very complicated script. You don't know what it is, but what we do know is that the root hash of the Merkle tree that expresses this very complex script is X. Now I'm going to use one of the branches, the third branch. And here's the third branch. It's the only one I revealed. You don't know what the other branches are or how many there are. And here's a proof that links that third branch to the root, showing that it was part of this very complex tree script. So now I can spend it, but you don't know what else was in there, who else was allowed to spend, under what conditions. Compare that to how it is today. If you do a multisig, every time you do a signature, you have to show all of the keys that could have spent it but didn't. If you do a Lightning Network spend, when you spend, when you close a channel, for example, then what you're doing is you're showing that this was a Lightning payment, and you show the channel public keys in the spend. You show the entire structure of the script. With Merkleized Abstract Syntax Trees, this would be much, much more private, much more obfuscated, but also much more efficient. You can represent a script with 1,000 branches as a tree with only 10 levels. And you know, that's fantastic. It really reduces the amount of data you need to present in a signature of a massively complex script. There's a couple of other important changes, including the change of how validation of scripts works. One of the important changes is to change the unused operands. In the old script version, these were called op-nop. Nop means null operand. It doesn't do anything. And they'll be changed with something called op success, which is interpreted by the script as a successful execution. And that allows you to do upgrades where you introduce new operands in the place of op success, and the script verification validation process is much more straightforward, and it's easier to do much more complex upgrades with future soft forks in the same version of the SegWit script. I know this is all very, very technical. There's a great post on the Bitcoin developers mailing list if you want to read all of the details. There's a bunch of other details about how this increases upgradability for future scripts too, but so far that's the bundle that is planned for the immediate future. Realistically, when do we see these features? Some discussions are about seeing a soft fork activation within the first 6 months of 2019, which introduces Schnorr signatures, Taproot, MAST, and a bunch of other little things that will make future upgrades easier. That would be by a soft fork. It's opt-in and it's backwards compatible, and would be a fantastic development for all kinds of privacy reasons, for scalability reasons. It includes some significant scalability improvements, and will also increase the privacy and scalability of the Lightning Network by making it much easier to open and close channels, and reducing the complexity of the Lightning peer-to-peer protocol through a Lightning protocol called L2ELTOO. So that's what's coming next in terms of development. Harry asks, who are the maintainers of Bitcoin Core, and is it possible to know what privileges they each have at any given time? So So Harry, first of all, let's disambiguate the term maintainer a bit. There's a difference between contributors, committers, and maintainers in an open source project that's hosted on GitHub of the style that the Bitcoin Core is. So let's deobfuscate those. Contributors are the people who can and do make pull requests. They're the people who are actively contributing code to the project through the form of pull requests. And all changes to Bitcoin Core happen through pull requests. Nobody goes and commits directly to a branch without a fully reviewed pull request. All change requests go through a pull request process. Maintainers are people responsible for gathering all of the change requests that have been approved by the broader community, by the social consensus of the development group, and which have broad consensus and acceptability to be included into the next release, and deciding how to sequence them, when to package them, in which order, and what each release should include. Although even that decision is heavily influenced by the collaborative communication and collaboration between all of the contributors who are commenting on the pull requests. And there's open discussions about whether features should be included earlier or later and which release they should go in. A maintainer's job is to schedule the releases and project manage them to a timetable, ensuring that the right changes are included, putting them through their testing and quality assurance steps, and then finally producing a release where a release is a bundle of changes with a specific version number. And that release then has release notes that tell you what changed, who changed it, who contributed, what effects it has, what any upgrade or migration steps are necessary, what the changes were, why they were happening, and collecting all of that documentation. The maintainer for Bitcoin Core today is Vladimir Vandelan. I think they have another maintainer who is now working to assist with Vladimir, mostly on the wallet side, as known as the wallet maintainer. I can't remember his name. Was recently given that responsibility. The overall maintainer is Orion W. or Vladimir Vandelan. And the number of contributors is anywhere from 30 or 40 people who contribute regularly to almost every release to more than 500 contributors who have contributed to different extents. And people come and go in this project. It's a vast, sprawling project. Now, there's another question, which is who has commit access to the repository? And that comes up all the time, but it's really not a relevant question. And the reason it's not a relevant question is because the people who have commit access to the repository don't use that commit access. If they do have it, they don't use it, because all commits happen by the project maintainers who are maintaining the releases. So it's a very different perspective. So who can sign with a trusted PGP key? Who can commit onto the repository? Who can register those commits into the repository, versus who decides what changes happen for each release and on what basis they decide, versus who contributes these changes. Those are all different roles. Specifically, at the moment, there are, I believe, 5 keys. I'm looking at some documentation here, which belong to Vladimir Vandelan, Peter Wohl, John Schnelli, Marco Falke, and Samuel Dobson. These are the 5 people who have PGP keys that can sign commits into the repository. But those are not necessarily the people who are making the commits. Primarily the release scheduling and committing of changes made by Vladimir Vandelan. And Vladimir Vandelan doesn't make decisions about what goes in. Really, Vladimir simply reflects and does the administrative work for the decisions that have already been made by the community. And in fact, exercises very little authority over what goes into a release, basically reflecting the decisions that have already been made in a very collaborative, open manner through discussions on the pull requests and the project notes of the Bitcoin core code. So it's very different than what you see at the surface. All right, let's go on to the next question. Yes, and there's a really nice article, by the way, for that. There's a really nice article by Jameson Lopp about the maintenance of Bitcoin Core, how it works, who has commit access, who has privileges, et cetera, et cetera. And it's called Who Controls Bitcoin Core by Jameson Lopp. It's a Medium article. If you want to read up on more of that, that's just one of the sources you might use. All right, and if that wasn't controversial, haha, let's do another one. What do you think about the use of checkpoints? This is a question by Javi, and it doesn't come with any other detail. What do you think about the use of checkpoints? So I'm going to have to use a bit of extrapolation and kind of interpret what I think this question means and what it's referring to and what the really the seed of this question is. So recently, a couple of weeks ago, the maintainers and developers of the Bitcoin Cash ABC branch, BCHABC, added a feature that was a bit controversial, which was a rolling 10-block checkpoint that prevents reorganizations for 10 blocks. So that means that you can't present a chain that reorganizes above 10 blocks. And this rolling checkpoint is a feature that was intended to protect Bitcoin Cash ABC against a specific type of attack, which is an attack that uses what's called secret mining. And what secret mining is where a rival hashing power is mining blocks without releasing them, without broadcasting them on the chain. And then once it has enough distance, so it mines a longer chain, and then once it's achieved a longer chain by a significant factor, it then releases that chain, and that chain causes a reorganization on the victim chain. I'm using the terms attack and victim here in computer security terms rather than political terms, so please don't read too much into it. But with secret mining, you'd have one chain mining, one group of mining power, mining secretly, mining a whole set of blocks ahead, say 10 blocks ahead, and then broadcasting all 10 blocks and the longer chain in one go, forcing a reorganization of the entire chain and invalidating say the 9 blocks that the rival hashing power has mined already on the other chain. And this is intended to cause disruption primarily, or to cause kind of like a hostile takeover of a chain. I'm not quite sure how you want to characterize that, but that's certainly possible within the blockchain logic. Now, compare this to how Bitcoin works. So to date, the Bitcoin chain does not have a rolling checkpoint, meaning that the algorithm allows for a reorganization of any length. The largest we've seen was back in, I believe it was April of 2013 or 2014, I'm not sure, when we had a glitch in the version upgrade between 0.7 and 0.8, which caused an unplanned, unexpected, and accidental, not deliberate, divergence of the blockchain into two competing chains that diverged for 26 blocks at the highest level. And then one chain was selected, which caused the other one to be orphaned and the whole chain reorganized 26 blocks deep. That's the deepest reorganization that's happened. And on a almost daily basis, you have one block reorganizations. And every month or so, you have 2 or 3 block reorganizations. And these happen due to simply the statistical variance in the number of blocks that come out within a 10-minute period, and how blocks are found in different parts of the network with differing latency, and they're seen by different parts of the network. These cause normal expected network forks, where the Nakamoto consensus temporarily forks, where you have 2 possible chains that are being seen by different parts of the network, and then they reconverge when one of them achieves more hash rate than the other. And eventually all of those reconverge. And the longest we've seen is 26, which is a very unusual event. But in any case, there's never been a rolling checkpoint. Now, there's another type of checkpoint, which is a checkpoint which is hard-coded inside the software, which puts a bottom limit and says everything below this block is considered established history and cannot change, what prohibits reorganizations below that. And that kind of chain checkpoint is different. So that's hard coding a specific hash in the software and saying this particular block cannot be reorged away. And that was used, in fact, in the 26 block checkpoint, I believe. So in the 26 block reorganization, I should say. So what do I think about this? Well, this is a change in the relative power of 2 different constituencies within the broader consensus mechanism. If you think about it, and I've talked about this before, consensus is a multi-constituency power, meaning that consensus isn't just miners. It's not just developers. It's not just merchants. It's not just exchanges. It's not just wallets. It's 5 different groups of consensus with overlapping membership. Miners, developers, exchanges, wallets, merchants, or if you like, miners, developers, and economically important node owners all contribute to emergent consensus by deciding which rules to follow, how to set the rules, what software to use. And when you put a change in the algorithm of what can be reorganized and what cannot be reorganized into the software, and you circulate that to software, such as the rolling checkpoint, what it does is it shifts a tiny bit of power away from miners and towards developers. So now developers are changing the way the protocol behaves to reorganizations. They're preventing certain classes of reorganizations. If you put hard-coded checkpoints, that's a more serious and more direct change of power, because now developers are deciding which chain is valid rather than allowing the proof of work consensus algorithm to make that decision independently, therefore the miners to make that decision together. So all of these types of changes and checkpoints do represent a slight shift in power in the consensus mechanism away from one group and towards another group. And then it's really up to you to decide what you think about how serious this change of power is. Whether it's a change of power that is justified. For example, you might think that in the case of a deliberate secret mining attack, or when someone has actually threatened to do exactly that and has telegraphed that they will do that and spend millions of dollars doing that purely to damage a chain in a competition between 2 forks, then is that a reasonable response to a mining group trying to take more power? Is it a reasonable response for the developers to take more power by changing the rules of reorganization, or take even more power by setting a hard checkpoint or repeated hard checkpoints in the software to prevent any reorganization? Again, that's a subjective thing. And that subjective thing, which is the decision as to whether you think this is a valid change or not, is how you express your role in consensus as a valid economic user of the softwares, because nodes that have economic power, nodes that use the chain in order to do transactions, that generate transaction volume, that are generating real, true economic activity, merchants, exchanges, wallets, end users, big companies, big whales, people who are doing a lot of transactions, whatever that may be, they choose what software to run. And in choosing what software to run, that's their contribution to the emergent consensus. And so if you see developers making this change, you can choose to run the software that you had before. You can choose to upgrade to the new software. And in choosing, you are expressing your own consensus vote. Guy asked, what are the important differences to know about using a Lightning wallet compared to a regular Bitcoin wallet? Are there differences? And what is the difference between a Lightning node and a Lightning wallet? That's a great question, Guy. And so theoretically speaking, or if we have an ideal design, there's probably very little difference between the user experience of using a Lightning wallet and the user experience of using a Bitcoin wallet. In both cases, the fundamental function of the wallet, which is showing you that you have a balance, expressing that balance in different units, maybe different cryptocurrency units. You have so many Satoshis, so many millibits, so many bits, so many microbits, whatever, versus expressing it in a fiat currency. Your equivalent balance in US dollars is X. That's a function of a wallet. And it would be the same in a Lightning wallet or a Bitcoin wallet. Whether you want to send or receive. In terms of receiving, a wallet will present a QR code that you can give to someone else or an address that you can give to someone else. And when you want to send, it can scan a QR code, or you can maybe paste an address that you've received through some other channel and send to that address. And then when you decide you want to send, you decide how much you want to send and what fee you want to pay. Well, in those cases, a Lightning wallet looks really very similar. So if you want to receive money with a Lightning wallet, you have to say how much you want to receive, and then it will generate a QR code or a long address, which is actually called a Lightning invoice. But it looks just like a long Bitcoin address. It's slightly longer than a traditional Bitcoin address. It's about 2.5 times longer. And if you give that to someone else, they can make a payment to you. So in that way, it's not different than here's my Bitcoin address, pay me. It's here's my Lightning invoice, pay me. One of the big differences, however, at least in the current stage of Lightning, is that people can only pay you if you generate an invoice, and you have to generate an invoice for a specific amount, which means you have to have an interactive step there. You can't simply give them a Lightning address and say, pay me whatever you want, whenever you want, and just keep giving that address to different people. You have to generate a specific invoice for a specific amount. There are some proposed changes to get around that. But for now, that's one difference in the experience that you will find different. For example, if I wanted people to give me donations, gifts on Lightning, the same way that people can give me gifts on Bitcoin. With Bitcoin, I have an address out there. It's published on my website. Everybody knows what it is. And if somebody wants to give me a gift, they could just take that address, send whatever amount they want, and that's a gift. If I wanted to do that with Lightning, if I wanted people to be able to send me Lightning gifts, I would actually have to do a couple more complicated steps, at least in the current state of the technology, whereby I have a form on my website. They type in the amount they want to do. They press submit. I have my Lightning wallet generate an invoice and give them that invoice on the screen, and then they can send a Lightning payment to it for that amount. So it's a bit more complicated from that perspective. In terms of sending, it's almost identical to a Bitcoin wallet. You scan the QR code, you hit send. That's it. or you scan the QR code, or you paste the address, which in this case would be a Lightning invoice. Very, very similar. You wouldn't be able to see a difference. Ideally, I'd like to see a user experience for wallets that combines both Bitcoin and Lightning wallets into one. There's no reason why you should have two different wallets. You should be able to have one wallet that can either make payments on-chain with Bitcoin or make payments off-chain with the Lightning network. And if you scan a Lightning invoice, it does a Lightning payment. If you scan a Bitcoin address, it does a Bitcoin payment. There are even some proposals to include both. So you scan a Lightning invoice, and if that isn't working for you for whatever reason, you can have a fallback Bitcoin address to do an on-chain payment. And it looks really identical to any other methods that might be used. So you could have one interface to do both. I think that would be ideal. There are some minor details that you want to carefully abstract in the user design. Now, the second part to this question is, what is the difference between a Lightning node and a Lightning wallet? And really, at the moment, there isn't much difference because most Lightning wallets are actually full Lightning nodes. And just like in the early days of Bitcoin, and then in the early days of Ethereum as well, if you wanted to have a wallet, you downloaded a full node implementation, and you had to sync a full node in order to have a wallet. And we didn't have lightweight wallets. Lightweight wallets that use a node that's somewhere else didn't exist in the early days of Bitcoin. And now we're in the early days of Lightning. Most Lightning wallets are closely coupled and attached to a Lightning node. Now, theoretically, you could separate the key management capability of a wallet from the network management and protocol of a node, and you could have your wallet talk to a node to get information about the network, but sign transactions on the wallet only. So you can eventually separate these two elements of the architecture. But for the time being, almost all of them are one thing. So every wallet is a node today. We'll see how that changes in the future. There are a few web-based wallets, but again, those are hosted wallets, in which case you're not running a wallet or a node. That's somewhere on a website, and somebody else has the keys. And guess what? In Lightning, just as much as in Bitcoin, your keys, your coins. Not your keys, not your coins. The next question comes from Bob. And Bob asks about running a full node with Trezor. I'm aware of the importance of running a full node and validating transactions for yourself. But I keep my Bitcoin on a Trezor hardware wallet. How can I help the network and myself by running a full node when all my transactions are handled by Trezor? And I believe this question could be asked for any hardware wallet. Really, this is about two separate aspects of monetary sovereignty, as Trace Meyer calls it, in fact, which I'm going to steal that expression and use that. Having your own keys, controlling your own keys, as I've said many times before, if you have your keys, they're your coins. If you don't have your keys, they're not your coins. You're relying on somebody else. So your keys, your coins is about sovereignty over the keys and the ability to apply digital signatures. And many people use a hardware wallet to have control over their own keys. There's another aspect of monetary sovereignty, which I've also talked about, which is the idea that if you are doing transactions on the Bitcoin network, if you're receiving money, for example, you want to find out, have I been paid? A lot of people will go in, type a website like Blockchain Info or some other website out there, and they'll put their address in and look to see if that other website thinks they have been paid. When you're doing that, what you're doing is you're outsourcing that role to somebody else. You're asking if they think you've been paid. You're not validating for yourself if you've been paid. If I want to check if I've received a payment, I would much rather ask my own Bitcoin node, has this address been paid? Because I know what version of software I'm running, what consensus rules I'm abiding by, which chain I'm on, whether it's fully synced. And I've configured that node to give me an authoritative answer. So if my node tells me I have been paid, I have been paid. What about combining the two? So combining the two at the moment is not easy. It's not something that can be done for beginners. Many of the lightweight wallets don't use your own node, don't give you an option to use your own node. And many of the hardware wallets use lightweight wallets or other company servers in order to get information about the blockchain. And that's really about user experience design and ease of use. Requiring everyone to run a full node in order to use a hardware wallet would obviously make it very difficult for people to control their own keys. So it's a bit of a compromise. On the other hand, if you do already hold your own keys and you run your own node, how do you connect the two? How do you use, for example, a Trezor hardware wallet or a Ledger hardware wallet, but instead of using it with the Trezor company nodes providing information about addresses, instead of using it with the Ledger company nodes providing information about addresses or whatever your hardware wallet is, how do you use it with your node? So far, I think the best solution I found so far is something called an Electrum Personal Server. And what this allows you to do is run a node and then run on top of that an Electrum Personal Server, which converts that information to a protocol that the Electrum software wallet can understand. And the Electrum software wallet then supports a broad variety of hardware wallets, Trezor, Ledger, KeepKey, Safety, BitBlocks, a whole range of all of the popular hardware wallets. And you can use it with multisig, and it has a lot of other really great features, up-to-date support for SegWit, native batch addresses, batch32, coin selection, UTXO prioritization, RBF, CPFP, a lot of great geek features that I like. So I use Electrum quite often, in fact, as a wallet. And by having Electrum connect to my own Electrum Personal Server, instead of connecting to the decentralized distributed Electrum servers out there, I'm increasing my privacy and I'm getting an authoritative answer. So the solution that I found that I like a lot is my own node, which is, well, a collection of nodes, in fact, with Bitcoin Core software, Electrum Personal Server, or a collection of Electrum Personal Servers connected to each one of these Bitcoin Core nodes, and then Electrum on a laptop computer or desktop computer that connects to the Electrum Personal Servers that connect to my own nodes, and then hardware wallets that plug in to the Electrum wallet to provide key management. And that gives me, in my opinion, the maximum degree of financial sovereignty, monetary sovereignty, both network consensus, self-validation, as well as controlling my own keys. There are other solutions out there. I was recently talking to Trace Meyer, and he prefers a solution which involves Armory, Bitcoin Core, and hardware wallets. That may also work. I think there are other solutions out there that do it too. Unfortunately, the best, simplest solution, which doesn't exist today, is Bitcoin Core supporting hardware wallets directly through the use, perhaps, of partially signed Bitcoin transactions, which I believe is BIP 174. I'd love to see that feature. Doesn't exist today. Okay, let's do a beginner question as the final question of the day. Is everyone still having fun on the chat room? What happened? Come on. We had so many emojis, complete sentences. It was all going so well. And then I look back just 5 minutes later, and there's a whole page, and there's 2 emojis on it. Really? That is funny. Okay, thank you. That's a bit better. Lots of emoji sentences. Last question of the day. I'm glad you're having fun. This question comes from Satender. Why does the transaction fee not show as a transaction output in the block explorer? Satender says further, just bought Mastering Bitcoin. I had this question looking at a sample transaction in the block explorer. Is there a public address where the transaction fee is sent? And is that address hidden on purpose? That's a great question, Satinder. And it's something that is very confusing at first, because you look in the block explorer and it's supposedly showing you all of the information that's in a block. And it seems that fees are not in there at all. And the true reason for that is because fees are indeed not in there. A transaction does not include a specific output for fees. That is not part of a transaction. One of the reasons is because that would require you to know where the miner wants the fees to go. So you would have to put in your transaction an output that could be redeemed by a miner, but then you don't know who's going to mine it yet. So that would be impossible. The second problem is, of course, that you'd have an extra output in every transaction. If you have 4,000 transactions in a block, that's 4,000 outputs for fees. And yet the fees are all going to go to one miner. Why do we need 4,000 outputs? So that's not how it works. The way it works is the fees are leftover, meaning that you have inputs that bring in a certain value into a transaction, and then you have outputs that spend less than that. The difference, the bit that isn't spent by the outputs but funded by the inputs, the overfund of inputs minus outputs, whatever's left over is the fee. So the way you make a fee in a Bitcoin transaction is by not spending it all in outputs, by funding the transaction with inputs and then spending less than the entire amount. And whatever is left over is the fee. It's implicit. It's not explicit. Okay, great. So it's not in the transaction. But where is it? Where is the public address that gets all the fees? Where is that payment? And here's the answer. It's in the Coinbase. It's in the Coinbase transaction of the block where the transaction is mined. So if you look at your little transaction in a block, and then you look at the Coinbase transaction of that block, right now the Coinbase reward is 12.5 Bitcoin. But if you look at the Coinbase transaction, which pays to a specific it's usually a paid to public key hash. It might be a different type of script, but usually it's a paid to public key hash. So you can see which address the miner is paying to. They're not paying 12.5 Bitcoin, which is the reward in the Coinbase. They're paying 12.513621 or 12.6 or 12.6253. Where did that 0.1 come from? Where did that 0.123 come from? That's the fees. And what it is it's the fees from all of the transactions that were included in that block added up. Do the math. Go and look at every transaction in a block. Probably best to pick a block that's relatively empty. And you can find those in the early days of Bitcoin. Same rules applied. You can find blocks that have 2 or 3 transactions. And within those blocks, look at the math. Or you could even run a little script if you want to. Try out your skills with the Bitcoin software and running scripts and interrogating the blockchain so you can see for yourself. Download a block, pull out all the transactions, add up the amounts of all the inputs, add up the amounts of all of the outputs, deduct the outputs from the inputs. You're left over with the fees for all of the transactions. And if you look at the Coinbase, the amount above and beyond the reward that comes in each block, which is currently 12.5 Bitcoin, or whatever it was at the time of the block that you look at, you'll see the Coinbase is more than that. That amount should correspond exactly to the excess input of all of the transactions, to the implicit fees. And that's where the output is. That's where the public address, where the transaction fees are sent is. it's in the Coinbase transaction. And the reason it works like that is because the miner, when they mine the block, they construct the block, they put all the transaction in, they count up all of the fees, and then they construct a Coinbase transaction that gives them all of those fees plus the reward. And then they try to find proof to make that a valid block. So the miner writes the Coinbase transaction. They know where the fee should go, and they put that in there. There are no fee outputs in any of the individual transaction. There's one fee output for the block, and it's the combined amount of reward plus all of the fees from all of the transactions. I hope that answered your question, Satinder. It's a little tricky thing, but it's very interesting how it's been designed and why it's been designed like that. I hope you enjoyed that answer. That's it from me. This has been our December live stream Q&A. It's been a pleasure doing this. I've had a lot of fun. Thank you for playing around with the emojis and making the chat fun for me. As always, thank you for supporting me on Patreon. Your contributions this year have enabled us to do so many amazing things, increase the staffing, increase the leverage, allow me to focus on generating great content and doing talks and videos, and spreading education to as many people in as many countries as possible, as many languages as possible, publishing new books, going to mainstream conferences and all of that. Your contributions make that possible. My staff and I really help you, really thank you for all of the help you've given us to make this a reality and to continue this mission. We've got big plans for 2019. And those plans are going to depend on us continuing to develop the Patreon community and having other people help us develop this mission. So again, thank you for all your contributions. Don't forget, January Q&A is going to be towards the end of January. We're going to start collecting questions now. Ask your questions, vote on questions, comment on questions, and come and join us for the next live stream. Hope to see you then. Thank you so much.